Hi students, today we're going to just talk about complex numbers. Complex numbers are numbers that have a real part and an imaginary part. Sometimes the real part isn't there. It's like 0, so it just isn't written down. And so we're going to first talk about how to simplify them and how to put them in standard form. Okay? The thing to remember that's most important throughout all of complex numbers is that the square root of -1 is always considered I. And that's just somebody's invention, and they determined that it would be that way, and so now there's all these things that relate to I. So if we take the square root of -9, now we know that I can't take the square root of -9 in real numbers, because if I said, oh, well, it's -3, but then you multiply -3 times -3, you get a +9. You don't get -9 back. So there's no way of doing it without some kind of invention to do this. So what we're going to do is we're going to separate this into two parts. Just like if I said the square root of 24, I could say it's the square root of 4 times the square root of 6. Right? So I'm separating the two parts. But I'm going to separate out the square root of -1 and the square root of 9. The square root of 9 I know is 3. And the square root of -1 by definition is I. Okay, so the square root of -1 is always I. That's an I. It doesn't look like it, but there. All right, so if I can separate out the negative sign separately, then I can find the square root of it. It's just going to have an I in it, which means that's the imaginary part. That's what I means, is imaginary. Okay, in other words, somebody invented this process, and so I guess they made it up in their imagination. How cool. Okay, the standard form always has the real part first, okay, and then the imaginary part. So, in an expression like 3 plus 2i, the real part is the 3, and the imaginary part is the 2i. That must have been from another problem. All right, let's look at some examples. All right, here's some examples. If I have the square root, I'm going to do this one first because it's easier. We know that the square root of 36 is 6. So if I divide this into the square root of -1 times the square root of 36, I know the square root of 36 is 6, so that part's easy, right? And then I know that the square root of -1 is always I. Now we don't write it as I times 6, we write it as 6i. Just the way it's always written. All right, how about this one? Do you remember how to simplify radicals? We think, well, what goes into 48? Well, you might not think off the top of your head that it's 16 times 3, but you might see that 4 goes into it, and 4 goes into it 12 times. And then you say 12, that's 4 times 3. Now, if you wanted to break the 4's down into 2 times 2, you could. It just seems a little harder. Okay, so I've got a pair of 4's. So I'm going to have 4 on the outside. I'm going to have a 3 on the inside. But I had that negative, didn't I? That negative means I'm going to have an I here. So it's going to be 4i square root of 3, because it's also the square root of 1, which is I. All right, this one, okay, the square root of 4 is 2, but I've got a negative, so it's going to be 2i. And the square root of 25 is 5, but I want to put it in standard form. And standard form always says that the real part comes first. So I'm going to have to turn this around and put the 5 in the front and the 2i in the back. All right? All right, good luck with this, guys. It's pretty easy.